Well, hello, ladies and gentlemen. Welcome back to Sums and Differences of Rational Expressions, and this is part 2. And I'm going to show you what we're going to be up against today. We're going to try to deal with some rational expressions that, well, they're just not, they're a little more to them than the ones we dealt with before. So you look at it and you go, uh-oh. They've got bigger polynomials on the bottom. So I look at this and I go, I still have to build common denominators, and I can't just get rid of stuff. All I can do is build them up. Kind of helps if you think of these as bundles that you can't break up. These are little sort of little bundles that are set in stone, I guess. So what are we going to do to build a common denominator? Well, here's what we're going to do. We're stuck with x minus 3, and we're stuck with x plus 2. So we're going to go ahead and multiply by this side by x plus 2. Now we've got to do the same thing on the top. Okay. And over here, we've got to multiply the top and bottom by, you guessed it, x minus 3. So sometimes these get pretty busy, but it's very logical. It's just busy. So let's see what we got here. So there's our denominator, which, by the way, there's no reason to expand out. Might as well leave it in its factored form, like that. The top, on the other hand, I do have to expand out, because I'm probably going to combine the terms with some of these terms over here. So I have a 2x times x, so that's 2x squared, and then 2x times 2, so that's plus 4x. Okay, then plus, and then what do we got over here? Well, on the bottom we have x plus 2 and x minus 3. Okay, and on the top I'm going to have x squared and x times negative 3, so negative 3x. So I'm ready to combine these terms. Okay, so we have our denominator of x plus 2 and x minus 3. And on the top, I have 2x squareds plus this x squared, so that's going to be 3 of them. And then I have a positive 4x, and I'm adding to it a negative 3x. So this would just be plus 1x. Now there is one more thing you should always check. If you can factor the top once you've combined these terms, sometimes it allows you to do some canceling with the bottom. So I'm just going to factor out the x, see what that top would look like. That would leave me with a 3x plus 1. Now is that going to get me anywhere? Is there anything here that I could cancel with stuff on the bottom? The answer is no, so I don't need this. It was a good idea. I investigated it, but it didn't work. So this is my answer. That's where it stops. So now let's move on to the next one. We're going to need the room here, so we're just going to clear the screen. And here's what we got. We got a 5 on the top, and we've got x squared minus 25 as a denominator. And we're going to add to that and a 4 on the top. And my denominator is x squared plus 10x plus 25. Okay. Now here's a really, really important tip. Before you go crazy here and say, oh my gosh, I got to build a big common denominator here, okay, really important tip. If you factor first, so factor, okay, if you factor first, sometimes these common denominators aren't as big and scary as you might think. So I'll show you what I'm talking about. See, if I factor this difference of squares, so x plus 5 and x minus 5. Okay, and then over here plus 4 on top, and we've got a little trinomial thing happening here, so we're going to need x times x, and we need to make 25 that adds up to 10. So So I'm thinking x plus 5 and x plus 5. Okay, so I see that this stuff is kind of already common to both. So all I really need to build up a common denominator, in fact, what is our common denominator? Let's write that out here. Okay, so let's set up our two fractions. I mean, it's still big, it's still kind of miserable, but we need an x plus 5 and we need an x minus 5. But beyond that, all we really need is one more x plus 5, because over here we have two of them, you see. See, this is everything we need from this fraction, but the fraction on the right needs one more x plus 5. So there it is. There's my common denominator. So x plus 5, x minus 5, and an x plus 5. Okay. Now, how do I build this up? Well, this guy here I'm going to multiply by the extra x plus 5, so top and bottom. And this guy over here, I need the extra x plus 5. Okay, x plus 5. All right, top and bottom. So here I'm going to have 5 x's plus 25. And over here I'm going to have 4 x's. And then I'm going to get minus 20. Okay, so here could be our final answer, I would like to believe, and I'm going to write it in a compact way. Since I have two of these x plus 5, so let me just say squared. Then I don't have to write it out a second time. And then I got my x minus 5, and then I got 5 x's plus 4 x's, so that's 9 x's. And 25 plus negative 20 is 5. Whew, all right, and there's nothing I can do to factor this top thing, so I think I'm pretty good with that. And so I think we're ready to, you know what, I think what we're going to do is we're going to stop. I was going to tackle the third example, but I think it looks really like it could be big and messy. So I'm going to stop there. I don't want this to drag on too long, and we'll just make it part 3. So we'll see you back for part 3.